All right. What is it? March 2023 Houston Job User Group meeting. Sponsored, made possible by Improving. And thank you, Stephen, for being here tonight. Telling us all about Debezium and changing the caption, how to do fun, fancy things. And again, thank you to Improving for sponsoring the meeting space and the food. And we are hiring as well. If you're interested, it's a great place to work. I absolutely love it here. And I do work for Improving, in full disclosure, but it's great. So without further ado, thank you, Stephen. And also, I dropped the door prize link in the chat. And Bill, I can give that URL to you as well if you want. And so, Stephen, please take it away.
Awesome. So tonight's talk is going to be a tale of kind of two stories. One of them is going to be about Debezium. One of them is going to be about Kafka Strings. The Debezium one is going to be fairly easy to understand, and it's really neat. The tool's pretty straightforward. When we get to the Kafka Strings and stream joining and doing domain aggregates, that can be a little complicated. So as we move along, ask questions. If you have any thoughts, comments along the way, please let me know. I am a staff specialist solution architect with Red Hat. I have been in the energy industry for most of my career. I've been doing software development for 20 years. I have a bunch of technical skills, but I also have been doing a bunch of domain specific specialties, and like I have a master's degree in energy trading from the University of Houston. So I'm one of the people that have done Black-Scholes by hand and all that type of stuff. So I understand trading pretty well, but I also understand development pretty well. So all my contact stuff is on the bottom right-hand corner, email, Mastodon, Twitter, blog, blah, blah, blah. Anyway, so happy to be here, and let's get moving. We do not understand anything until we understand Kafka. Okay, so we're going to start with Kafka because you have to understand Kafka to understand any of this. And the only thing you really have to know about Kafka is that Kafka is not a message broker. Kafka is a distributed log. Why is that different? It's different because that's what actually creates the ability to have such great throughput with this architecture, right? It's the ability to be able to do parallel processing because of the key ordering at the partition level for Kafka. So when a producer is producing messages, it can produce it to a topic. A topic is logical, but each topic can have multiple partitions. Which partition it goes to is a one-way hash function on the key itself. So anything that has the same key always goes to the same partition.
You think of it topic like a database table in a way. If you're struggling with the concept of you have, say, topic might be dedicated to a particular data type, not necessarily, but
or a file.
Or a file, yeah.
More of a file. I would say more of a file, like routing to a file.
Because you're appending to it.
But it's an append log, yes.
Yeah,
so like that kind of is a so. But the thing to think about, the thing to really grok on this is the Kafka clients are really smart. Traditional message clients are really dumb. So Kafka clients do a lot of work. The producer client does a lot of work in terms of asking the broker ecosystem, the Kafka instances that are running the Zookeeper specifically, well, not Zookeeper anymore, but it's specifically saying, where do I need to go put this stuff? And then it actually does the routing, like it specifically goes and puts it on the broker, on the partition in the right spot. So the producer's smart. That's actually not even the thing that you really have to understand for this. What you really have to understand is the consumers are super smart. So consumers have consumer IDs or consumer group IDs, one or two. Those identify and keep track via Zookeeper, via the no longer Zookeeper in the Kafka binary, the offsets on the partitions of the things that it's read so far. So the consumer keeps track of that stuff in the Kafka system itself, right? So when a consumer dies and the consumer comes back, first thing it does is says, hey, based on my consumer ID, where was I? It asks the broker goes, you were here on these partitions, on these topics, you were at these offsets. Cool, I'm gonna start reading from those offsets again, okay? So that's the thing that we really have to understand here. Got it?
And that's opposed to a traditional queue.
A
which
message
does not-
broker is transaction. It's like it's either marked as read already or not, and it's a queue. So if you're done with it, it deletes.
It's ephemeral, yeah.
Yeah. This is not, it's there. I can go back and go read. I can say
Any number of consumers and different consumer groups can read from that same
Yeah.
topic,
at any time, in any order,
as long as the data's still there.
as long as the data's still there.
Yeah.
Kafka's default is forever.
7 days.
I thought it was forever.
Compressed logs, compressed topics are set or forever.
This is what, I wasn't sure about this either, so.
I thought it was forever.
Default retention is
I
7
could be
days.
listening. Jim is correct a lot of the time, so I never like to look at Jim and be like, no.
Default
Jim did the test, actually.
default is delete,
7 days?
in 7 days, yeah. Whereas if you have a compressed topic, it's forever. But yeah,
I was wrong earlier. I apologize.
it's okay, it's a lot to
Yeah.
keep in your head.
And I don't even know if that default changes readily or not. I don't, this is.
You can set it, but
Yeah, of course, yeah.
Got a lot to cover here. Let's
yes,
keep going.
of course, keep at it.
All right. Debezium, what is Debezium? Debezium is a change data capture platform. Change data capture is nothing new. There's nothing new. There's been plenty of things that do change data capture. This is just the next iteration. And really what this is this is built around the Kafka ecosystem. So it's how do we do database change data capture, but plug it in easily and quickly to Kafka, right? It's fully open source. Red Hat, right? That's what we do, is build open source software. It has a very active community, which is pretty cool. A lot of contributions, a lot of continuing contributions. But really, at the end of the day, what it does is it actually listens to the transaction logs of the database. And so I have a demo, we're gonna get into the demo, and we'll see, and I'll show you exactly where it's going with that and stuff like that. But the cool thing about this is there's no burden on the database.
You can almost say it acts like a replicated database, a database replica.
And it's.
I say no.
No, okay, all right.
It-
Pardon me then. Pardon
It
me.
reads the transaction logs.
Okay,
And interprets them.
yeah,
into
okay.
Kafka events. That's all
Yeah.
it's doing.
And it's not written by Oracle.
Or there's an Oracle implementation.
Oh,
Okay,
really?
so why do you need this? What's the big deal about this? Right? Back in the day, Java developers, all we had was two-phase commit. That was great, right? It was, I can write a bunch of records into a database. I can start a transaction. I can start a distributed transaction. I can write a bunch of stuff into records into a database. And then I can put a bunch of messages in a message topic or a message queue, right? And then I can have all of that be part of a two-phase commit transaction, meaning if it's all or nothing in terms of data and messaging. So then when the transaction committed, it all committed all at the same time. That was great. And it worked really well. That doesn't work anymore because none of this stuff supports two-phase commit transactions. Kafka included. So if Kafka would have just supported two-phase commit transactions, it's easy, right? If you would just include the Kafka actions alongside the database stuff and it's all good. Kafka doesn't support that. So what you end up having like Elasticsearch doesn't, cache updates, you know, if you're using an in-memory data grid or something like that, they have their own transaction mechanisms, even though some of them do support. Regardless, the problem is in the middle of your code, if I do insert into a database, and then I'm doing write to Kafka, if I get halfway through my writes and my process dies, now I'm out of sync. My database is updated, but I didn't do those other two writes. And when my process comes back up, it doesn't know that. So that's the problem. So what we're doing now with change data capture is we're going to stream those changes out of the database. So your transactional context is still just the database. And then once you have that in your Kafka topic, then you have a whole bunch of Kafka consumers that can go and do whatever they need to do at a Kafka level to propagate that data. Questions, comments? Got that? Okay. What does this look like, right? So what this is doing is it's looking at the transaction logs and it basically interprets them. It takes the row data that's associated with the table, and for every row, it basically turns it into JSON structures. So if you see here, it has a before, it has an after. If it is, and then if you look at the op is a C, right? So there's a couple different ops.
Itty bitty, but yes, like leaning over my screen, I can see.
So there's an op that's C, there's an op that's D, there's an op that's R, and there's an op that's it, right? Great. That's all.
Yeah. See.
Better to help. So in this case, when it's an operation that's a create, there was nothing before, and then after there's something. If there's an update, there was something before, and then there's something after. If it's a delete, there was something before, and there's nothing after. So all the records will reflect the opcode. We're going to actually do something a little bit different, which is we're going to go and do a special message transformation piece of Debezium that even makes it even easier. So you don't have to even deal with all these big before after envelopes and do any kind of logic.
Nice.
It's just domain objects. Serialization formats out of the box, JSON, Avro, but you can use protobuffs, you can do whatever you want to. It's just harder. And then cloud events can be used too. We're not going to talk about that. Red Hat integration, change data capture supports Oracle, MySQL, Postgres, SQL Server, MongoDB, and DB2 on Linux. All of them really work. So like Oracle, MySQL, Postgres, those are really log-based. Very cool, very easy. SQL Server is not. SQL Server does not do logging the same way these guys do. So you end up having what Debezium actually does is go and sets up a bunch of database triggers and change data capture tables that does intermediary data capture as part of the transactions. It does like interslicing of transaction data.
Wow.
It's more complicated. SQL Server is more complicated because Microsoft. Mongo's the same way. It's document, so that's a whole nother beast as well. So I kind of classify these as like the Oracle, MySQL, Postgres is one way. SQL Server is a little bit different, and Mongo's a little bit different. But all of that is abstracted away. Once you get all the stuff into the actual Kafka topics, then it all works the same.
Yeah.
So there is some. It helps you with the normalization. So all the data changes are captured. So you don't have to poll. A lot of people, they just, when they do data synchronizations, what they're doing is they're saying, hey, every 5 minutes, I'm going to go read this database table and say, give me all the records that have an update timestamp that's changed since 5 minutes ago. What happens if the record's been updated 14 times in between? You're only going to get that one change, and you need those other 13 changes. If you just need the latest and greatest, and there's no need to keep track of any of the other state, poll, right? That's fine. Right, as long as it's not overloading your database in terms of the query performance.
Like the connection pooling and.
Yeah, but this is if you need all the database changes and things like that. There's a lot of other cool stuff in here, and it can capture deletes. And you got old records and new records. It's real simple. If it's query based, right? It's simple, and if it's log based, it's all of those other things, but it is not completely simple. Like this is kind of complicated. So there's going to be a lot of caveats that I'm going to be going along the way. One of them is if you own your database, cool. You can go in and make the changes to your database stuff that you need to do. It's not out of the box. There are configurations on the database that you have to change if you didn't set things up, right? And I'm going to go through a couple of them with Postgres, but like Oracle's the use case that I like to talk about. Because most enterprises, it's like, I have this huge Oracle table, I want this huge Oracle database that I want to change. You have to turn on log miner and do some other like configuration stuff in your Oracle database. If you're gonna do that, you have your regression tests ready, because you're gonna go turn on all of these other features, and then you need to regression test that it didn't impact your actual application's performance in any way. If it doesn't impact your application performance in any way, you're good to go. And then everything else can be, because it's just reading logs at the end of the day for the other stuff. If you do not own your database, if this is a vendor database, if this is like a vendor system and it's their database schema and it's their database implementation, if you decide to go turn on logging that the vendor never turned on, they may not like that. So talk to your vendors, talk to your people, and get them to make sure that there's a support exception in place if you're doing something different than what your vendor's expecting, because if they call and you're having a performance issue with the actual application itself, and they start doing introspection and they're like, who turned on all this stuff? They may be able to point at that and be like, well, there's your performance issue. So just get the support exception if it's not your database. Got it? Okay. What is Kafka Connect, right? So this is the third piece of the puzzle. Kafka Connect is literally just this runtime that's been developed that gives you the easy ability to be able to take stuff and shove it into Kafka, and then pull stuff out of Kafka and shove it other places. That's it. It's just a bunch of plugins that basically does basic serialization back and forth, maybe some slight data structure changes.
Yeah, very, very minimal transformation.
Very minimal transformations, right? And you got two sides of the world. You got sources, right? So if you go, when you run a Kafka Connect thing, you can say, go listen to this S3 bucket and shove whatever the file structures that are in there, their CSVs, take those and shove them into Kafka for me, and it'll JSON out for you or whatever. Nothing exciting. Same thing on the sync. The sync can be like, hey, whenever rows come across in the Kafka topic, take those and go shove them into Elasticsearch as JSON, and let Elasticsearch do the indexing and auditing, right? All good. So this is an example of Kafka Connect.
So I'm guessing with Kafka Connect, you can create your own connections.
Yes.
Yes.
You can create your own connectors as well.
Connectors,
Yeah, so it's open source APIs. I think you can implement 2 methods or 2 classes or something, very minimal. There's a lot of examples available as well on GitHub.
Yep. So the configurations are actually really simple. We'll talk about that because I'll show you the Debezium configuration. You can run it in standalone. Don't run it in standalone.
Yeah,
Run it in a distributed mode.
Yes.
So it's high availability. This runs really, really nicely on OpenShift Kubernetes. So there it is. I'm moving fast because we have a lot to cover.
Sure, that's fine.
Debezium connector, right, is a Kafka Connect connector. So that's all it is Debezium went through, took the Kafka Connect interface and implemented it for Debezium, for what Debezium wanted to do. What are we doing? Again, we have a couple databases over here. We got Kafka in the middle. We got some Kafka Connects. So you get, and this is logical, right? This could be one Kafka Connect, right? But it's like on both sides of it. So here's forgive the drawing. So we have 2 Debezium Kafka Connect connectors. One that's listening to MySQL, one that's listening to Postgres, and it's shoving stuff into Kafka. Awesome. Now you can write then you can have your connectors on the other side that are taking those events and shoving them into Elasticsearch. Now, the cool thing about this is if all of a sudden you need to push this someplace else, it's just another connector, right? So you can easily scale with this. You can easily, this is the fan out pattern that creates a lot of value to the organization, especially like, in a trading organization, right? If all of a sudden you have a Kafka topic with all of your trades, right, in sequential order, right? Having all of your downstream systems all have access to the trade data, the trade events as they're happening, is where it's. Question, comments, thoughts? I love this. I love this slide. This is one of my favorite slides.
So one comment, if you don't care about records getting deleted, you just want to listen to ads and updates, you can use like a JDC connector or the Mongo connector, but again, you're not going to get the delete events.
Yeah.
So big problem there. If you do care about delete events, that's when you definitely want Debezium.
Is that an issue with JDBC?
No, it's just that there's no way for the JDC connector to share, hey, something was deleted.
You can't query something was deleted.
Oh, I see.
Yeah.
Now you could do like 2 file matches if you
Yeah.
keep state, but
But that's a headache.
that's-
It's the nightmare.
Okay.
Okay. So what are we doing here? Let's play with some Debezium. Hopefully is that big enough for everybody? If not, I can make it bigger. Good.
Might be a little bit bigger, yeah.
A little bit bigger. I had it on 18 or
Here's a way you can like do like a controller command and then mouse wheel.
Oh,
I don't have mouse wheel.
Okay.
I just have to reopen it. There we go. Is that right?
Yeah.
So we're going to be using Podman. Podman is the open source version of a container runtime. Synonym is Docker. So it basically, you can do an alias, Podman equals Docker, Docker equals Podman. All the commands work almost exactly the same. This is just an open source way of doing it. And it is, you can run it rootless. So you don't have to run as root, which is really nice from a security standpoint to have container runtimes on all of your developers' desktops and not be running root. Thank you. Podman. So we got Podman installed. We got Podman Compose installed. Again, same thing. We're going to get going. We're also going to use the KC Cuddle, right? So Kafka Connect CLI. So you don't have to do curl commands to interact with Kafka Connect.
Yeah.
You just use KC Cuddle,
Yeah.
and that obfuscates all of that complexity. We are going to get started by doing the Podman Compose up. And that's going to kick us off. What are we kicking off? First thing we're kicking off is Postgres. So we're going to spin up a Postgres container. Postgres 15, super secret passwords. And we are databases. This is a very selfishly done demo. I'm trying to replicate an energy trading risk management system, right? And so I'm trying to emulate a vendor service that we're trying to make events out of.
So quick question. So for the folks who are maybe watching out on YouTube, how much RAM should they have on their computer to run this kind of a setup?
As much as humanly possible.
Okay, like 16 gigabytes?
I have 16 gigs on this. This is an older Mac. It's not
Okay,
an M1. The fan won't even turn on.
okay, wow,
You're good.
okay, good.
Okay.
and Podman's really lightweight too. So.
It's
Okay, good.
very lightweight.
Good, okay. Want to make sure, because I know I've run into issues myself with not enough RAM.
Yeah, you start a Docker Compose and it never comes up.
I think my Docker machine, so when you set up the VM, so remember, containers are Linux. So there is a VM that's actually running in the background. Even Docker, like there's a VM that's running, that's a Linux container, or that's a Linux VM, right? I think my Linux VM, is allocated like 4 gigs of memory, and it runs all the stuff.
Okay, great, wow,
Yeah.
good.
Anyway, when you set up the Podman machine, you can set how much memory, how much CPU. So like I gave it 2 cores and 4 gigs.
Okay,
And so it's good.
good.
So here's the first thing that we're going to look at is right there. We're passing Postgres a command line argument. for the wall level. So that's the write ahead log. For Postgres, we're giving it this logical marker. So we're telling it, hey, we want you to log everything, and we want you to log the before and after for any transaction.
Okay.
Okay?
Always.
Yeah, if you don't do that, it does write to the write ahead log, but not as much. So you've
Interesting.
got to do this to do that. So this is the first kind of like, it doesn't just work out of the box. There's things you have to do to the database. For Oracle, that you have to turn on log miner, and then you have to like set up, there's a couple security pieces that you have to set up.
Okay.
Oracle's a little bit of a, as Oracle does, it's a little bit more difficult. But it's really powerful. We're also, while we're spinning this up, we're also going to do, we have this init SQL, so we're setting up some tables. Ignore all of the, I created a bunch of, like I created an actual kind of robust schema here with a bunch of foreign key relationships. We're going to ignore all those for now. Really what we're talking about here is this one parent-child relationship, which is the trade header and the trade leg. So when you think about a trade, quick trade structure lesson, right? When you think about a commodities trade, if I'm trading natural gas, right? Maybe I'm trading natural gas on a monthly basis. So I'll have a trade with a single leg for the month of May for 10,000 MMBTU for $3.50, whatever, right? One leg, right? If I want to model a different trade where I'm trading like a whole year of natural gas, I might have a trade that is 12 legs, with each leg representing a different month, because each month may have a different volume, or each month may have a different price, that kind of thing. So the header leg relationship is because an individual trade or individual transaction execution could have multiple legs. Another example is like a fixed float swap in a financial sense, right? So if I am going to give you a fixed amount of money and you're going to give me whatever the index is on a monthly basis, that would be two different legs, right? I'm giving you money, you giving me the other one. Okay. So that's really what this structure is. If you notice, the header doesn't have much in it. It's got a trade ID, primary key, cool, start date, end date, execution timestamp, what kind of trade type it is, very anemic. Actual trade structures are a lot more complicated than this. Here's the second thing that's a alert of like, hey, this is different, is you'll notice that we're altering the table, replica identity full, both on the header and on the leg table.
Wow.
What
Yes.
does this do?
I was gonna ask.
Atomicity.
If you don't do this, when you delete something and it has a foreign key relationship,
Yeah.
it will send the delete. Debezium will pick it up and actually push it out, but the only data that it includes is the primary key. So in our case, when we have a trade leg delete, I need to know not only what the trade leg is, but I need to know what the
What the information was.
what the trade ID was, specifically the trade ID. And I'll show you in the Kafka Strings why that is so. So that's the secondary thing, which is not that big of a change in terms of a database change. So if you can, if you own the database, boom, it's easy. But if it's not your database, check with the vendor, make sure that you can do this, and it doesn't impact your performance at all. But it's not that big of a deal in terms of change.
So by default, the entire entity is not included in that type of log that you were talking about?
Deletes,
Deletes. Oh, okay.
only deletes.
Ties in.
Everything else works perfectly, just deletes. Okay, so that's it. That's the structure. It's simple. So let's move on. Odd name proposed. We got Kafka up and running. We got the new Kafka. So if you'll notice, no zookeepers.
Yeah.
That's easy.
Yes. Get it out of here.
And then the last thing is Kafka Connect, right? So those are two different things, right? Kafka Connect is a separate thing, runs in a separate,
So you're only running one broker.
one broker, one single broker. one single Kafka Connect, it's all local, keeping it simple. If you look at the Kafka Connect, the only thing that I'll point out is the image comes from Debezium. Why? Because Debezium packages up all of the Kafka Connect classes that are Debezium based into the image itself.
Okay.
If you don't do this, and you just use the regular out of the box Kafka Connect, you have to then package in and build your own image with all the connector classes and all the jars and everything else that you want to use in Kafka Connect.
Okay, wow, so you can't just use a Debezium jar and then like have that as a Connect plugin? Wow.
You gotta plug it into the ecosystem. It's gotta be on your class path.
Yeah, so you couldn't just have the Debezium jar on your class path?
You have, if we're doing containers,
Yeah,
you have to plug it into, you have to shove it into the container. If you're not doing containers, then you just have to have it on the class path.
okay, okay.
That's it. All set up, ready to go? Cool, awesome. We got all that set up. Podme Compose is up and running. Let's go apply our ETRM connector. So our database is running. We got our Kafka stuff's all up and running, ready to go. Let's go apply our ETRM connector using Casey Cuddle and create the connector. Look at that. That was very simple. What did we actually do? This is the connector. All right, so this is Kafka Connect. I'm gonna start talking about Kafka Connect, and then we'll switch really quick to Debezium. Kafka Connect is, you have a name for a connector. That your name has to be unique in your Kafka Connect. And then your config starts, and the first thing is, what is the connector class? So that's the implementation of Kafka Connect that you want to use. Everything that you see below that is configuration that your connector needs. Okay, so everything below here is all custom to, this is all the Debezium stuff. This is the only stuff that's Kafka Connect. Oh, okay. So we're using the Postgres connector. Neat. Plugin name. This is telling you, hey, go use the write-ahead log. There's a different way that you can actually read the transaction logs. This is saying, go use the Postgres output, which is the write-ahead log. So this is telling, hey, go read from there. Everything in the database dot configuration should be self-explanatory. It's connection information. Provide transaction metadata is the first kind of fun thing. So not only will it output the transaction events themselves, like the updates to trade header, or updates to trade leg, it actually sends out the transaction metadata into a separate topic. And I'll show you that here in a minute. We tell it what our topics are going to look like. So our topic prefix is going to be ETRM because it's the ETRM. I would name it whatever the source system is. So if it was a particular ETRM, I would name it that or whatever. We name the topic transaction to transaction. I'm actually going to move that up there because they're better grouped together. We're going to include the table list of all the things that we want to listen to. So in that case, we got those two tables that we want to listen to, header and leg. You can wildcard this as well. So you can do all kinds of stuff here. The more you include, the more topics that get created.
It's gonna make it star.
Yep. Yep. Topic creation enable is equal to true. So this is a neat thing because we don't have to go create all these topics. When you set it to true, the Kafka Connect will go connect it. Default replication factor, we only got one node running, so guess what the factor is? One. Default partitions, so that is the topic creation. So when it creates the topic, it's going to create 3 partitions. 3 is the magic number for some reason in Kafka. This is where we start to have some fun. So instead of outputting this other structure, we want to spit out JSON. If you don't include this, it still spits out JSON. the difference is that it does it in like this archaic hash map structure where they actually does the schema of all of the, like the columns for the row. So it'll tell you what the row name is. It'll tell you what the,
So
data
it's
type
correspondent.
is. So that spits out first and then the data then spits out afterwards. It's easier to do the JSON converter. All of this is on GitHub, so go
Okay.
grab it, go play with it.
Nice.
That's one of the things that I recommend is rip out the JSON converters and see what gets spit out. It's actually,
Yeah.
I think I actually had a scratch of it.
It kind of looks like a SQL insert where it shows like it lists the columns and then the values like way down. So they're all like separated and it's hard to read.
Yeah, it's,
Yeah.
I can't, I don't have a scratch. It's, I did have a scratch at one point that had the structure in there.
Yeah, that was my favorite thing when I realized IntelliJ will highlight the column name if you put the insert in.
IntelliJ. I love these things. So we're spitting everything out as JSON. See the converter, the schemas enable is false. That'll spit out the schemas for you. We turn that off. I know it's not in that. And then this is where it gets fun. So the transforms is unwrapped. So the transforms allow you, this is the thing that's going to say, instead of spitting out the before and after, I'm just going to spit out the JSON. I just want the data structure, please. And I do want some other things added that are some of those other fields that are like the metadata related stuff. But if you look here, I'm going to add those fields. I'm going to define them here, and they will get added to the record itself with the prefix of __. So it's just going to go right on the record. The record's going to be a create or delete or read or whatever.
That's kind of like that's one of the transformations. So that's like a map.
Yeah.
Very simple. There's a bunch of other different transformations. You can write your own transformations.
Oh, yeah,
and
yeah.
Plug those in.
Mhm.
So there's a bunch of stuff to do.
Yep.
Really neat. I forget what rewrite does. I think that's what it does is it actually spits out the before. If you don't do the handling mode rewrite, it just spits out a null. Decimal handling is string because we are lazy in this. Keep in mind Java, big decimal, double, and JSON do not mix very well. We're using strings because they're simple. If
Yeah.
you're going from string or you're going from string to double to big decimal, you're gonna have a bad time if you're handling money. So, buyer beware there. And then we're turning off tombstones by default. Debezium will do tombstone records.
So a tombstone, if you're not familiar with a tombstone in Java, in Kafka rather, it will, when Kafka broker receives a tombstone, it is an instruction to delete that particular record for that particular key.
And we're already going to be doing that by handling the delete record coming out of Debezium. So we don't want double nulls.
Right.
That's it. And so that's it. So that's our ATRM connector. That's all hooked up and ready to go. Any questions on the connector? Kind of straightforward. Like I said, the Debezium stuff is fairly simple.
It's also well documented too, if you do have more questions.
It is very well documented. Kind of the neat thing about it. So now we're in, so I did a Poppy and exec interactive shell into the Kafka broker that's running. So we're in the Kafka container, pod, whatever you want to call it. We're going to do a quick list of all of the stuff. So if you look, we have our consumer offsets, obviously, that are, kind of out there. We have our Kafka Connect status things that we had set up at our Kafka Connect. And then we have our trade header and our trade leg
Topics.
ready to go. Two things, if you wanted to do transaction output, for some reason, the transaction output one doesn't create the topic for you. Why it doesn't, I don't know, but it doesn't. So you have to go create it. And then at the end of the thing, we're actually going to be outputting domain aggregate trade object that's not the database stuff. So we need a topic for that. So we're gonna go create those topics real quick. Again, 3 partitions.
The 3 partitions, you want a primary and 2 replicas that can take over if the primary fails.
What?
You have 3 partitions. No, that'd be replicas. Never mind.
Yeah.
We can't have replicas because they don't have a broker.
Yes, rack protocol is 3 is the magic number. Okay, so let's go
Okay.
look at what's out there. Side note for anybody that is using the Kafka console consumer and things like that. Sometimes these things take a second to actually connect into Kafka and start reading stuff. So if you hit execute on this too fast and then go and do something, it might not be set up and ready and read that. So give it a second. We're gonna do from beginning. Because we started up our Kafka Connect, it actually reached out into our tables. It looked at the offsets and the diffs, and it goes, hey, look, there's stuff that's out there. And there's the stuff, right? We had inserted in our init thing, we shoved some data in there. Well, I put a couple of header records, and then there's 2 trade legs that are associated with trade leg unit 101. So you'll see the op down here is read. That means it was just reading new stuff that was already out there. Okay, so it's not, there wasn't a transaction because it wasn't running. It's just reading it. There's a lot of configurations that you can do around how you read stuff in, how much to read in. If you have a table that has 10 million records and you go do something, you're gonna have a bad day because it'll reread 10 million records or whatever and then shove them into Kafka and probably turn your laptop into a jet engine. No, but seriously, like if you dealing with some really big tables and stuff like that, there's a little bit more involved in terms of making it good. But anyway, there's our stuff. So there's our headers, there's our leg table, we got it. So now Kafka is populated with these change records. And so that is kind of the Debezium side of the world, right? So let's go open up.
Where did you have these inserts for these reads? Were they polling or what? Or did you insert them in the?
I did that in the init.
Oh, okay.
I had some stuff at the end. I was just putting in some stuff data.
Okay, cool.
So we bashed into another shell. So this one is the actual Postgres that's sitting there. Let's go and do some SQL stuff. So we're going to create a new trade record, a trade header. We're going to insert a new record, and then we're going to insert 2 trade legs all in the same transaction. Okay. Cool. What happened over here?
Lot of data.
We're listening to our.
There it is. C.
So this is interesting. The first thing that you'll see here is what is this? That's the transaction record. So you'll see the transaction record has a status for begin. There's another one, status of end, right? And in this one, in this transaction, you'll see that it has some data collections. And basically this is telling you there was a transaction. Its ID was 775. That ID is unique. So you can do queries and joins off transaction IDs. Well, I'm not doing this in this demo, but you can. It's complicated, but it's neat. And it also tells you what happened. Well, it doesn't have to tell you what happened, but it tells you that things were done to tables. So if you see here, trade leg, event count 2, because we inserted 2 records, and trade header, event count 1, and you got your transaction timestamp. Cool. What else it spit out was our new trade record, right? So 102, a bunch of dates. You'll notice it uses epoch dates. That's pretty neat. For serialization. So days since each.
So without that,
Oh, okay.
without that object configuration, would this look different?
Yes,
Oh, okay.
yes. Now you'll notice, see the underscore op. Remember I said, hey, I want to add some of the metadata into the record itself.
Yeah, yeah.
It appends it to the end of it. So up to trade type ID is my actual record. Anything that's underscore is metadata about the Debezium transaction.
Okay.
And it's just in the record. It's cool. It's easy.
And it's
So-
Pythonic.
Yes. If you're into that sort of thing. So so now we have, and you'll notice the other thing that's changed is our op was create. It wasn't create. Cool. Let's go do some updates. So, this trade leg here, 103, trade leg 103 has a price right now of $2.84. We're going to update 103. Oops. Don't want that. This is fine.
No Vim keys and container.
No. Update trade leg. Okay, so we're gonna update the trade leg 103. We're gonna set the price to $3.85. Update transaction. Here's my record now. Here's my op. Let's update trade leg 103, and there's my price, $3.85. Cool. Let's delete that stuff.
Oh, here comes the delete.
We just deleted trade leg 103. And here's your delete record. So there's two things that you'll see. One is my op is D. I still have all the data. So now this is, I need these two things for when I do my string joins. The other thing it says is there's underscore deleted is equal to true, but a little bit of double duty in terms of that, but that's just out of the box with SMT and wrapper. Has some other neat stuff in there. So the trade leg is the source table, you know, the transaction, source transaction ID 777, 777, 777. Okay. Questions, comments, thoughts? It's fairly straightforward.
Yeah.
Especially if you have tables and it's just, I want to spit out some tables, dude, this is easy, right?
Yeah.
So it's fairly simple.
Well, I know we spent months trying to get Golden Gate up and working, spitting out JSON for this type of stuff.
I have no commentary about the product of Golden.
It's terrible. So this is considering, I mean,
That is not Red Hat.
this is like one day. This would have turned the entire thing into one day, basically.
Okay. No questions, no comments. Everybody online, are they still with us?
Yes.
Okay, cool.
Any questions from online?
That's like one half of the presentation,
Okay.
right? So now we have these Kafka structures, we have these topics, they're set up, they're ready to go. Let's talk about streaming, because at the end of the day, in this scenario, I don't want the header, like my downstream consuming systems, I do not want them to have to know that there was actually even two tables involved. They don't care that there's a header and a leg table. They want to know about trades. They want to know canonical formatted trade structures. They don't want to have any system knowledge of upstream systems. I want everything insulated and abstracted away from them. I want them to be using my data that I transform for them in the structures that everybody agrees upon internally. That way, you can add on another system that creates trade data, And as long as it outputs in the same canonical format that you're expecting, it goes directly into the same trade topic, you're good to go. That's, okay, so all that's neat. But how do we do this? We have to join this data back together in Kafka. That's where Kafka Strings comes in. So Kafka Strings is basically another set of functionality that sits by the library on top of Kafka clients, right? So it's just some abstractions. There's two main abstractions with Kafka Strings. One is K-string, which is fairly straightforward. It is, hey, I want to represent a stream just like I would represent a Kafka topic, right? So the K-string is fairly simple to set up. This is the example for that, is our actual transactions as a string. So the way you set it up is you have the streams builder object, right? And you say, I want to create a stream. I want to tell it what topic I'm going to use. So my etrm.transaction topic. And then just like everything else in Kafka, you got to tell it how to do the SERDES. So the serialization, deserialization, right? So it's going to be, I'm going to be consuming that topic with a string, deserialization for the key, and then this etrm transaction SERDES. Where is that coming from? That's coming from, I'm injecting it. I have a separate producer for all my SERDES because I can use it in different places. This is really simple stuff because at the end of the day, right, what I'm just using is Debezium has the stuff out of the box where you can just say static references on Debezium SERDES. Give me a payload JSON serialization, deserialization for this etrm transaction, which is a record, right? Java record in the wild. And if you see here, all we're using is the Jackson JSON properties to abstract away. So the JSON obviously is coming in like event underscore count. I want that as a camel paste proper Java nomenclature. The underscore. I don't want it to be Pythonic. So so I have all my SERDES here. You see here, it's just the same thing. So my etrm trade header is the same. I just abstracted it out. There's all of my columns, right? Including all of my operational stuff that's in here. So yeah, I have my header and my leg and everything else.
So you're actually gonna handle the transaction.
I can in this, but I'm not. I'm just creating a stream.
You're just passing.
All I'm doing is listening to it and I'm peeking.
Oh.
So I'm printing it out for you.
Yeah.
And then I'm gonna filter it. So you can actually do streaming stuff using the streaming API. So I can do filter, I can do map, I can do all the things that are normal streaming stuff with K-string. So I'm gonna filter it because I don't care about the begin transaction. All I care about is the end. Who cares about the begin? If a transaction fails, I don't want those changes.
Yeah, that's right.
So I only care about the end, and I only care about the tables that I'm listening to. I did a filter on those. So it's going to print out all transactions, and then it's going to show the filter transaction, which is just the end.
Wow. Okay.
It's just going to print that out. That's not even the fun join stuff yet. Honestly, just ignore that. It's just going to come across a lot. Okay. K tables. K, this got me, right? So this is the thing that I had to, like, it's only with 4 lines of code. There's a lot here, okay? So first of all, I have a streams builder, right? I'm using the same streams builder. The streams builder, as you're building stuff, is keeping track of things, and it builds at the end. It does this streams builder build, and it builds this topology. The topology, the closest equivalent to the topology is a DAG, right? Things go in order. So as you're adding things to the strings builder, you're creating new streams, new K tables and things like that, there is an ordering that is implied by the way you're setting up your topology. So the header and the leg, like those two tables, those are independent because I'm just using the strings builder. But if you look down here, I'm building something else, and I'll explain that in a second, but I'm using the trade leg K table as a basis for that. So it's going to do the ETRM trade leg K table first before it does any work on this other K table I'm building. Does that make sense? So it does build a dependency graph. And you'll see it in the logs here in a second. So that's the first thing, is like, I'm creating this table. So I'm creating this table, and the table is, hey, here's my topic, right? How do you consume it? I'm consuming it with my serialization, deserialization, right? Same thing. You'll notice here, this always returns a stream, right? So what I'm doing, you can't just do dot table, but I don't want the JSON structure. I don't want this to be my key. I just want the number. And we'll do that. I'm doing that for a reason. That's for the join later on, to make the join easier. I just want the number. So I'm doing a map where I'm creating a new key value pair with the trade ID and then the value of each art trade pair. So I'm just replacing it. And then I create a peak. So we're going to take a look at it. You're going to see that come across in the logs. And then I create the actual table. This is the other cool thing. And I wouldn't say it's cool. This was the complicated piece of it. You got to materialize that. This is actually creating a RocksDB file database.
Yeah.
It's a file, like a file structure.
Yeah. It's a merged database.
Yeah. And I don't know a lot about the particulars of it. I just know that it creates a small little bitty database and it serializes the database to Kafka. So you're storing small databases in Kafka.
Oh, I thought it was
I thought it
local.
was local. Yeah.
Is it, it'll do, oh, neat.
Hmm.
Oh, so it uses that as, will it actually, if it's gonna query it, will it use KSQL?
KSQL is a different thing.
Yeah.
Oh,
So it's the state. So yeah, so you're creating the state store. So that it can be rehydrated on another consumer.
Yes.
Yeah, I just didn't know that that was in a topic. Yeah, I thought it was local.
And then you got to tell it, the last thing you got to tell it is to table and materializing it. And then how, again, how do you serialize it? You're handing it the SERDI again. And in this case, because we mapped it to number and object, the SERDIs that I've had it is an integer.
yeah, because of
4
that.
lines of code, a lot of complexity here.
Yes,
This is a lot of reading
this is the stream's magic.
and a lot of Googling.
Yeah,
There's a lot of Googling here to get those 4 lines of code right. Okay, so we got a header table, K table. We got a leg K table. And right now, the header has trade ID as the key and the actual object. Leg K table has trade leg ID as the primary key and the leg is the topic. When I go to do the join, I have to do the join like you would do in SQL, right? You would do it inner join on trade ID, table, trade ID, trade ID. Kafka Strings doesn't allow you to do that. There's no such thing as like a join in that sense. So
Yeah.
the first thing we have to do is I have to figure out how to get a collection of all of the trade legs and associate that to another K table that has trade ID as the key. Because the keys, when you do a join, the keys of the 2 K tables have to be the thing that joins.
okay.
That was another lot of Google.
Yeah, 'cause this whole thing is like type safe, right? So.
Yeah.
When you construct that thing, it's gotta be integer
I need
to,
like a foreign key join,
You
you
don't
know,
do they have it?
key tables.
Yeah, maybe. Like this is the part where like I know that I get on
This
the
is
Debezium pretty
the
well.
limit?
This is the
Yeah.
part to where I'm like, yeah, probably, like,
No, this is sound.
I don't know.
I've been able to do it. When I work with KSQL, you could have it join on primary foreign keys.
KSQL and K-strings,
Yeah,
2 different things.
yeah, I don't know.
It,
I don't know if they will.
one sits on top of the other.
One sits on top of the other, but it's 2 different things.
So-
Conceptually. Okay, move on. So as I said, so now we have all the header, we have all the legs. Now we're gonna do the aggregation. So what I need to do is create another K table, and this K table is going to be, the primary key is gonna be trade ID, but then it's gonna have this other object called ETRM trade legs. What is that? It's a wrapper around a map. So we have a map of all the ETRM trade legs with all of the ETR, and so this inner map, the key is the trade leg ID. And it's just storing all of those trade legs in a map.
This is an association table. Well, I mean, in terms of the stream, but
Kinda.
yeah.
But if you look at the update method, when the ETRM trade leg comes into update, I look at the opcode, and if the opcode is delete, then I go to the map and I remove it. If not, if it's a create or an update, I put it. So if you put it, and there's already something already there, it overrides it. If there's not, then it inserts it. Right? And then I'm also returning the object itself. So it's parental. If you look at this, you'll notice again, remember, it is ordered. There is context in terms of ordering. So the trade leg K table is going to update, and then this is going to fire off after that is updated. So we're mapping to trade ID and trade leg. So then now we have that trade leg in the trade ID, and then we're going to group by key. And this, it creates that K grouped stream. Honestly, that's all I know about this, other than like, this is another.
Yeah, you're like going through that association to get to the next one.
Right.
So you're kind of like creating a join. Yeah.
Well, that's where the aggregates come in.
Oh, I see.
So the aggregate basically has 2 callback kind of things to it. The first one you'll see here is, hey, if there's nothing there based on the key, create a new one. So this is how you tell it, hey, create new. And then the second one takes 3 arguments, the primary key, the actual value, and then the aggregated value that you created. So you'll notice the integers going in, the ETRM trade leg is going in, and then the ETRM trade legs is also going in. So then I actually call ETRM trade legs dot update and the trade leg, and then it goes into this, and it either puts it in the map or deletes it. So at the end of this, it also materializes again into a key value store as the legs table, and you got to tell it again how to serialize, deserialize. And then I created a separate stream from that, and I'm just peeking at it just to log it out. So we'll have some understanding that. We'll pause for a second.
This is the aggregate function. It kind of looks like the to map in
Yes.
in
it does.
Kafka Strings.
Yes.
Yeah.
Yes.
Okay. Where this is the center, the second argument is the merge function. The first one is the supplier for an empty.
Yeah.
And then the last one is, you might have to go back.
Initializer, aggregator,
Yeah.
and then the materializer.
The actual output.
Yeah.
Yeah, okay. Totally, okay, that makes sense.
So you can do aggregation and you can do reduction. Right, so the reduction is.
That's what I'm seeing. I'm seeing the reduce, yeah,
You see the reduce.
yeah,
This is the aggregate.
okay.
And there's a whole bunch of other really cool stuff like time window K-streams.
Yeah,
We're not
it's
talking
wild
about
stuff.
That's really, it's a really,
Look for suspicious trade activity.
yeah.
Yeah.
Windows are, it's crazy. Okay, so now that we've gotten to line number 85, we got our header, we got our leg, and we have our legs aggregation at the trade ID level. So those three things are in state. So our last thing is we are gonna do our actual join. So if you look here, we're gonna output it as this trade object. Again, it's just a record, but it's my record. It's the one that I defined. It's my canonical record. I love this record.
This is the output.
This is my output.
I see.
Look
Okay.
how simple it is. To be honest with you, it's pretty much the same structure as coming in from the database table. But what I would be actually doing here is filling out and pulling in other data to then make this huge. Because most of the time when you're doing a callback, the actual output of the data you want ends up being like this 12 table join. Exactly.
Well, and it could contain a bunch of fields you don't
Right.
care about at all, right?
So this is a very simple version of it, but in the real world, this would be a huge with a bunch of leaves and all this, right? Okay. So we're gonna do our join. We're taking the trade header. That's the parent. We got the children. We're joining with the trade legs. Remember, the keys are the thing that it's joining on. The keys have to be trade ID and trade ID.
Yep.
Those have to match. Okay. So then the second thing is the value joiner, right? So there's the joiner. What that's doing is it's basically taking the value of the first and the value of the second, and you can use those as arguments. So what I do is I pass that to these methods down here, and I say, go create a trade. Here's the header, and here's the legs. Here's the aggregation. So what I do is like, if it's delete for a header, just return null. There's my tombstone. That's what I'm tombstoning. So that's why I turned tombstone off,
Ah, okay.
because I'm already tombstoning it. If that's not, then I stream map and create all of my trade legs, my canonical trade legs, collect those, dump those into a list, and then I create my trade with all the stuff that I wanted. Notice I'm transforming epoch day, right? The start date that was coming in, remember I pointed out there was epoch day? You know what epoch day is?
January 1st, 1970.
So
Yeah.
when the date comes across, it's an integer and it's days since that day.
Yeah. Days? Oh,
Days.
epoch day.
Yeah, epoch day. So you can pass it as an integer, right? That's
Yeah.
much smaller
Mhm.
in terms of size. Epoch day, epoch day. Same thing for the millis. for
Oh,
the
and then you use
execution
milli,
timestamp.
oh, okay.
Surprisingly, that's only like.
And that's how
it's
many
only like
millis are
9
in a
digits
day?
long.
That's how many millis are in a day?
That's how many millis since January 1st, 1970 at midnight.
Oh, I was just wondering, why would you need all three? Epoch day,
One's
Oh.
the start date, one's the end date for the trade, and then the
Oh.
third one is the exact execution timestamp of when the trade executed.
I see. Oh, okay.
So there's my trade. So I transformed it now. This create trade returns a trade object. And then I tell it, hey, I gotta materialize this thing too. So now I materialize that as a trade table. My certi is again integer, which is trade ID. But my value is the actual canonical trade object. I then take that table and I dump it to a stream. So now it's a K stream. I'm gonna peek at it so I can print and so we can see this madness happening. And then the last thing is I do two, and then I tell it the topic name. So it'll just spit it out to a topic. So this is a lot of really cool stuff to where it's like you can take this, shove it over here, create another topology that listens here, shoves it over here. Like there's a lot of stuff that you can do in intermediary steps here, in an event-driven way. And then of course, produced with, always got to tell it how to do, sorry. Okay. Let's start this second.
Excellent.
It does keep some state there.
Yeah,
There is
and the K
state
tables.
in the K tables, but so it's, when you set up so here is, I tell it where the state dir is, but let me start it up and I'll show you what I'm talking about. So maybe that's something I need to actually look at. I might be absolutely dead
Can
wrong.
you tail that?
No, it's a folder structure.
Oh,
I'll show you
okay.
in a second.
You have to watch tree or something.
And then it's gonna be a bunch of bytes.
By the way, we're writing all this in Quarkus. Oh, what happened?
Oh,
Oh, I put clear.
yeah.
I've been typing clear.
Clean.
Thanks, Nathan.
Have to do something in these.
Okay. Nathan should know clear means clean.
Got a plugin.
No.
Maybe we can write a plugin.
Yeah.
Okay, so this is,
Maybe clear.
so this is starting all of the Kafka stuff. It's starting and initializing all kinds of stuff. We'll talk about all this here in a second. We're gonna do a little quick so temp, page streams. That's the folder structure that's there. So what's in?
Zero underscore zero.
Thanks. So that's why I think that.
These are
there's
the
nothing-
logs, the log directories.
I think this is a temporary thing for when it's doing the processing.
Yeah, it's got a cache, right, for about the.
If you look at the
length of time.
numbers, I think the numbers are the DAG structure or whatever.
Huh.
We gotta do some more research. And here's what, this is an educated
Can you
guess.
throw them into T-sort?
Watch this. If I'm back in my Kafka topics.
Oh,
Yeah,
yeah, it's
If
doing a bunch
intermediate-
of.
you have intermediate topics where you're doing the by key, group by keys.
So if you look at ETRM trade legs, there's one, the trade table has a change log. And then I don't know what the other repartitioning.
Repartitions are for whenever you join the K tables, so they have different number of partition counts. Or if you group by key, it has to take and shuffle the keys to the correct partitions so that it can actually perform join.
Okay.
Oh,
If I understand correctly.
so it has to keep an association between what topic or what partition it's going to when it does the join. for
Yeah,
Each one of
so
them.
because you want to have the same number of partitions on both sides in both topics. And if you don't, it has to do a repartition for you.
What do you want to look at? You want to look at the,
Yeah,
see what's in here. It's probably gonna be binary, so it's gonna spit out garbage.
let's see. Here comes the sweat. This is the
Nothing there.
the peel sweat.
There's nothing there.
Maybe if you, you probably have to do one, right? Don't you? Or
I've already processed some of them because I started the
Yeah.
thing.
what if you read from the final topic? The output.
Yeah.
Oh, is this a watch?
This is everything. Yeah, it's
So like there's a trade leg map. So there's the serialization. I don't know what topic that's coming from.
right.
It's coming from one of those topics, but there's the serialization of my ETRM trade leg,
Yeah.
ETRM trade legs object.
Oh, you know what might, it might only do it if it can't immediately join it.
Maybe,
Yeah,
maybe.
because then it would have to persist that one for a little bit to wait, you know?
maybe. We all have them? Yeah.
Yeah,
Okay,
No.
this is cool.
okay, so I'm gonna start just listening to the trade topic real quick. And this will be the final thing because it's already 15.
Yeah.
Trade key, whitelist trade, so we're listening to the trade. So now let's go back to our Quarkus thing. So you'll notice, look, hey, look, we read in a bunch of stuff. There's some transactions that we read in, headers, legs, filter transaction, header, leg. But the biggest thing you'll notice here is the things that came out. There's trade 101, there's trade 102. So it's right. So what was in Debezium, what was in the database is all good with the world, right? It's all good.
Very nice.
Now let's go do some database stuff. Insert. All transaction, prints it out. There's our header with 103. All transaction, there's the end. There's my filter transaction, which is just my end. So you can do filtering. That was just a kind of demo that you can filter just like a string. There's my leg that's coming into my leg K table. There's my second leg that's going into my leg K table. There's my leg aggregation. The key is 103, which is my trade ID, not my trade leg ID, my trade ID. And that contains my trade legs object, which has my map, which has the two legs in there, 104 and 104. And it spits out trade 103 with my canonical trade structure.
That's cool. Nice.
Wait, hold on.
Yeah, I'm really seeing the,
Okay, we're gonna update the price.
how
Though.
the aggregate works.
We're gonna update the price on one of the legs. That's it. So we're not touching the header. We're not touching the other legs. We're only touching one of the legs. Transaction, the leg fires because the leg updated for 104.
Yep.
Notice it takes a second. And I don't know if this is because it's just kind of a little underpowered because I'm running it on a laptop. Boom. So there's my leg aggregation.
Oh, okay.
103, EPR and trade legs. 104 as in updated with a price of $3.25. And then it spits out what I want. The trade for 103 with its fully aggregated domain object with all the values correct, including the updated price. Cool. Good, delete that record. We're just deleting one of the legs. Transaction, filter transaction, just the leg for 104 fires.
And there's your.
There's my
reduced
delete.
aggregate.
Op is equal to D. There's my leg aggregation now. It has a single leg in it, which is 105. So that's up to date. And then it spits out my trade for 103 with a single leg. Cool. Let's go delete the other leg and see what happens. Transaction, leg 105, op D. My leg aggregation is now empty. My trade is now empty. No trade legs. No trade legs. Cool. We're gonna create a brand new one because
Delete the trade.
we're gonna do the trade header here in a second.
Oh, okay.
I wanted to show it in a bigger context.
Yeah,
So
oh, okay.
we created trade 104 that has legs 106 and 107. Right, so there's our trade 104 that just came out. We are gonna delete. Where trade ID is equal to, where trade ID is equal to 104. So we're deleting from trade legs where trade ID is equal to 104. So we're deleting both of the legs and we're deleting the header all in one transaction. What should come out of the other end?
Tombstone.
Tombstone.
What do you want your tombstone? Pepperoni and sausage sounds good, thank you. Bad joke.
So there's our transactions. There's my header with my op-d. There's my legs, both of them with op-d.
I don't really understand the tombstone thing.
Good things for a second.
So it finds the key and it deletes the record for it.
Oh, okay.
But it's a theoretical. It's a,
It's not actually.
remember, it's always an append. You can't delete anything.
Yeah.
All I can do is update the state of it. So if you look here, my
Right,
leg
so it writes a
aggregation,
null value for that key.
my leg aggregation,
Oh, so that egg doesn't work.
right? But look, that's actually what spits out to my trade topic.
Yeah.
Is the key is 104, the value is null. My consumers have to know that when they see a key that comes across with a null value, that means delete.
Yeah.
It's
Now, if you had a compacted topic in Kafka, then any prior value would disappear.
yes,
Yeah,
If you have
and
a
if you
delete-
queried it.
If you have a delete topic, it'll retain all those other versions of the record
that is correct.
for whatever your retention policy period is.
All right.
Okay.
Anything that we want else that we want to see here? Are y'all convinced that the power of the Debezium with the K streams? It's a lot of work,
Yeah.
but once you get it running, once you get it working, it's pretty powerful.
Yeah. Oh, yeah.
So we're gonna exit.
And then legacy can do whatever it wants. So like, it can just SQL it up.
We're gonna exit. Oh, wait, okay.
I like that. That's an interesting concept.
Any questions, Alaya?
And then the last thing then is.
No, I'm good. I have been trying to get Debezium to work at my company, and I had to put in heartbeats. I don't know if you've had anything. My bin logs used to get deleted as a result, and I would get errors in my connect in the connector. So I had to put a heartbeat. But what we ended up doing in the other than the sandbox environment, we had to enable the create topics to false. I had to create all those topics by hand. Like the history one, we have the 3 offsets, and then the heartbeat as well. So that there were 6 that had to be created if you turn off the create topic enabled to false.
That's all very good to know. Thank you, Alaya. Thank you.
There's my contact information, Alaya. Still need help, shoot me an email, I can help.
Great, thanks.
So, contact information, GitHub is out there, it's all public, so you can go grab it, pull it down, play with it, break it. Built some Quarkus is pretty cool if you don't know about that. And that's it.
Cool. And were you able to find the chat, Alaya? I dropped the door prize URL in there.
No, I wasn't able to.
Okay.
Do we have the QR code?
Yeah, I can generate one real quick, I think.
We can put it up there.
Yeah, a second. Just a second here.
That's I was actually recently doing something similar, and but it doesn't actually use the DB. It just puts all the logic in one consumer. so that it sequences the whole thing.
Okay.
Very similar to, well, like understanding it as like a CRUD operation, so. But yeah, I was wondering the next step, like how would you do transactions, and you just let the DB do it, which is, I love that idea.
Oh, I forgot to
You know what I
mention, that's the other piece of this.
Oh,
Sorry.
okay.
Let me share my screen.
Oh, sorry, okay, yep, there you go.
One more time. Yeah. If you have access to your database, just use the outbox pattern. So the outbox pattern is, it creates a table, an outbox table. And so you're doing all your inserts and your updates. And then so like in my case, when I go to serialize the trade that I want to serialize out to my users, I put that as the payload in this table. And then Debezium just listens to this one table,
Okay,
Oh,
and then it pulls out the serialized payload and puts it right into the copy.
oh, wow, that's nice.
This is
So
really,
you-
really nice
Well-
because you don't have to do any of the K-string joins or anything else.
Okay, huh,
And because it's, the outbox table is part of your database transaction, it's not a dual write.
okay,
It's all as part of the ACID client transaction.
nice.
So if you have the ability to do this, please, for the love of God. do this.
I see. Okay.
Okay,
Yeah, that's kind of something what we are using at my company.
yeah,
I'll share my screen real quick here
Sorry.
and, sorry,
That's really, thank you.
so, Alaya, this is the QR code for the door prize survey.
should I start with this? Should I sit
No,
like
that's just
outbox?
a cool, I like
Okay,
that.
yeah,
So
Yeah.
if you want to grab that with your phone, Alaya, you can go to that webpage and, fill out the survey for the door prizes. We got IntelliJ Ultimate 1-year subscription. We've got a Structure 101, 1-year subscription, as well as a plugin for IntelliJ and Eclipse, and helps identify problems in your code base. And then another one called a Sonar Graph from a company called Hello Tomorrow. They also make a great refactoring workbench. They also have a great community edition as well. It's very powerful, and you just use it to help analyze your code. With the ultimate, with the more advanced versions, it gives you the ability to do some sandbox refactoring, stuff like that. And then a Webucator voucher for a free training course as well. So if you want to sign up and toss your name in the hat, try and win, definitely one good possibility. So and also improving is hiring. We're hiring Java developers, Scrum Masters, .NET folks, and let's see what else. Yeah, business development folks, or AKA sales team, account executives, .NET developers, Java developers, DevOps engineers, data engineers, and Agile coaches. So if you're interested, improving is definitely hiring. It's a great place to work. I absolutely love working here. Anything else, Steven? Anything you want to share out?
Shoutouts.
nothing, Red Hat, open source for life. And if you're interested in enterprise OpenShift, enterprise Kubernetes, that's simple to use and out of the box. Ready to go for your enterprise. OpenShift is where it's at.
Cool.
That's it.
All right. Thank you so much. All right. Thanks for joining, Alaya.
Great, thank you.
All right. Thanks. Bye.